All right, good morning. First talk of the day, so, hope everybody had a little bit of coffee at least. So, who am I? InfoSec guy, been on red team for a while, now on the blue side for the last 4 years, 5 years or so. Live in Frankfurt, as he said. I'm an American expat. My wife and kids, they all have 3 passports apiece. I have only 1, but it lets me stay here. So this talk, I'm going to talk to you a little bit about my experiences with Linux and Mac threat hunting. I work inside of InfoSec at Elastic. I'm not on the sales team. I'm on the InfoSec team. So my job is protecting the actual Elastic networks. And of course, we do that using Elastic tools. So Elastic as a company, we're distributed worldwide, 1,600 people. Most of the people work from home. So that's, I sit at home working on my laptop all day long. All of our developers work from home. Most of our salespeople, travel. They'll work from trains, planes, coffee shops, wherever. And it's my job to help protect that. We only have 2 physical offices, or 2 big physical offices. Endpoints are mostly Mac, sprinkling of Linux, sprinkling of Windows in there. Basically, when a new hire starts at Elastic, they say, "What do you want?" And the person picks what they want. So we've got a lot of Macs. The sales team, for some reason, has a lot of Windows. And the developers have whatever they want, which we've got, all sorts of flavors of Linux out there. Our actual infrastructure all lives in the cloud. So we've got infrastructure in all 3 major cloud providers. So it's not just an AWS security shop we've got to deal with. We've got GCP, Azure. We've got IBM cloud stuff. We've got Tencent cloud. So it's, gets exciting sometimes. And yes, all of our build infrastructure is publicly facing. About once a week, we get a bug bounty person trying to collect a reward for finding our Jenkins. So, yes, we know it's out there. All right, so what's this talk about? We're going to talk about the problem that, we're seeing in InfoSec, kind of a solution that we've got from the endpoint. Going to talk about the quick overview of Auditbeat and the new modules that are out and how we use them, and then how you can use them for alerting, incident response, and then threat hunting on Macs and Linux, and then automating a lot of this stuff. All right, problem for defenders. It's good for privacy, not so good for a lot of the network defenders. I'm sure a lot of people have felt this out there. You're collecting, Zeek data, you're collecting data, you're at your network perimeter level, and just everything keeps getting encrypted. Now everybody, I saw a bunch of Twitter wars back and forth about the pros and cons of DNS over HTTPS at the browser level. Visibility is going down. It's just a fact of life. So you can either sit and moan about visibility going down. You can try to break the encryption at your perimeter on all of your users and really mess with their privacy, which also, doesn't go over well with a lot of the labor unions over here in Europe. Or you can try to find a different solution. So also the other thing with the network logs, if you're looking at 443 traffic, okay, you got a 443 connection to AWS. There's no context there. It came from a system, but you don't have any context. It happens millions of times a day, so nobody's going to actually fire an alert to that. Yeah, this is just, a little quick example of the DNS over HTTPS. This is a PowerShell thing I wrote back when I was doing red team type stuff that you can slap into PowerShell Empire, and then all your DNS inside of your command and control payload is encrypted. While everybody's, arguing over whether the browser should encrypt it, the attackers are already doing it. Yeah, too many logs, not enough money. This is the other problem. So if network's getting faster, 5G's coming out, everybody's getting faster and faster internet. And of course, your applications, your computers are using this faster internet. They're creating more event logs. They're creating more traffic. And so if you try to collect all that, your prices just keep going up. Anybody who's, tried to collect all this stuff and store it on AWS or store it in some sort of logging server, you start to see your monthly bill just keep going up every single month. It gets harder and harder to justify that. So I always try to look at, okay, for this data source, how many detections per dollar am I going to get? How many times am I going to find an attacker using this data set, and how much is it going to cost? What's the trade-off? Because, everybody would love to collect everything, but the accounting people are not going to let you do that. All right. So the solution, for now at least, we'll see how this goes in the future. Endpoint visibility. So a lot of people have been talking about this with Sysmon on Windows systems. You can do Auditbeat as well, and that's what this talk is about on the Linux and the Mac systems. So the key is to get the logs streaming almost in real time off of the endpoints and into a central place. That way you can do all the magic with it, basically. Yeah, and it gives you context. So once again, TCP 443 to ABWS on your firewall, I don't care. I'm not going to look into it. Calc running as root, making a TCP 443 connection, that's probably something you need to look into. And without that endpoint data, you're not going to have this context. Okay, so here's the overview of Auditbeat. That top line is directly copy-paste from the website. Lightweight shipper. Lightweight as in it doesn't use too much processing power. That all depends on your configuration. You can change your configuration and have it use 100% of one core. I don't recommend that. It contains 3 modules inside the Auditbeat config, the auditd, the file integrity, and then the system module, which is the new one, which I'm going to spend most of the time talking about. So the auditd module, Linux only, this is the one, so the older versions of Auditbeat, this is the original way that we were monitoring the Linux boxes. It just uses the auditd subsystem. So if you're familiar with auditd, you'll be familiar with this module. So I got the pros and cons there. The pro uses the same configuration options as auditd. If you've spent any amount of time messing with auditd, you may consider that a con because it's not the most intuitive configuration options. Auditd lets you, if you just turn auditd on to log everything, it will log every single syscall on the entire system as it happens. That is extraordinarily noisy. You do not want to do that on an enterprise. Like if you've got a malware sandbox, it's great. You can see absolutely everything that malware does. On the sales guy's computer, you don't want to do that. So you definitely have to tune your configuration. That's where the cons go. If you turn everything on, a single process start will have 8 to 15 events for every time any process runs. The file integrity module, this is, it's in the name. It monitors the integrity of files and folders. So it gets works on Linux, Mac, and Windows. Monitors for changes to folders, changes to attributes of files within folders. So if somebody goes and adds a sticky bit to a file in a folder, you'll see that. They go and modify Etsy hosts, you'll see that. Really good for monitoring changes in activity in folders. It also does an initial scan once you first load it, and it gets the hash of all the files. So if you can turn that off from a collection point of view if that's going to be too noisy. But if you can, and if you can afford it, it's great to collect because then you have an initial file hash of every file on all these critical folders inside your domain. So the system module, that's the core thing that I'm going to be talking about here. So released in Auditbeat 6.6, that's just got updated in 7.4. It's kind of I always think of it as Sysmon for Linux and Mac. Sysmon is the Windows version if you're not familiar with it. Microsoft made Sysmon. We made Auditbeat. Collects 6 different data sets. Not all of them are available on Mac because Apple likes to lock things down and not be friendly. But it's better than nothing. So, the polling versus, I think I get into that, state versus event. So when you're setting up your configuration file for system module, there's states versus events. The system module, most of the modules work on a polling basis. So you say every second, show me all of the processes running on the box, and show me all the new processes that have started in the last second. So you can imagine the disadvantage. If a process starts and stops in between that second, then you're not going to see it in your logs. With network events, that's really bad. But we just changed that in 7.4. So the state is, you can say, okay, every 12 hours, show me all of the installed applications, all of the installed packages, or every 7 days. It all depends on how much you want to collect. So when you're configuring Auditbeat, pay close attention to the system, the polling versus the state. And that's where I was saying you can tell it to consume a lot of your CPU usage. Like say you really want to see everything, you can tell your process data set, instead of pulling every second, pull every 10th of a second. And you'll start seeing your CPU usage on a core spiking up. All right, so these are the data sets: the host data, login, package, process, socket, and user. I'm going to be going through those. The host data set, this is available on all three Mac, Linux, and Windows. Collects the current state information about the host, IP address, all the Mac addresses, the IP address, the uptime. And so this is one of those ones that we like to collect every 12 hours or so, because then, you kind of get a snapshot of what's going on. So then if there's any changes to it, you can say, okay, every 30 minutes, show me if the IP address changed. Show me if the host name has changed. Show me if the uptime has changed. And so it'll say, hey, the box rebooted sometime in the last 30 minutes. Every host gets a unique host.id in the logs. So as the host name changes, the host ID stays the same. So as you're building out your dashboards, things like that, the host ID is the one to pay attention to. Login dataset. This is Linux only. We don't have this on Mac or Windows. Successful failed logins, reads UTMP. So nice thing with the all logged in users, that'll show you everybody. You'll get spool, you'll get Apache. It's not just like actual real human beings. It's all of the users on a Linux system. So you kind of get an idea. So you can whitelist a lot of that stuff if you know that these guys are, these system accounts are expected to be there. Oh yeah, and for remote IPs, you get the like SSH logins, you get the remote IP address, and then the terminal type as well. So like TTY1, TTY0, etc. Package dataset, Linux and Mac. This isn't like all the applications installed on a system. This just uses like DPKG, RPM, or Homebrew. So on a Mac system, you'll see all of the Homebrew applications installed, but you won't see the actual applications from the App Store that have been installed. I use file integrity for that because it just shows me all the folders in the applications directory. Gets you a pretty good idea of what apps are installed on system. Yeah, definitely do not set the polling on this too low, because every single time it's trying to get all the installed packages, it runs DPKG or brew, and it says, show me everything that's installed, and then it compares it against the little local database and sends you an alert with any of the new updates. So inventory management, this is a great thing for inventory management. We had, every month you get a vulnerability alert comes out. It's like, oh, this version of Nginx is vulnerable. So I just go into my dashboard and say, okay, show me everybody who's got got Nginx installed, and show me all the versions. And now I can say, okay, these 3 hosts need to go update they need to run apt-get update. Process database or process dataset. This is the key one you use for the threat hunting. Mac, Linux, and Windows get the process name, the hash, current directory, a lot of the same stuff you would expect from Sysmon. The parent information about who started the process. Every process gets a unique entity ID. That's kind of like the process GUID in Sysmon. So then you can use that entity ID to track track further execution if you see that process opening sockets, things like that. So you can have polling as well. So you can say, hey, every 30 minutes, show me every single process running on this system. Once again, I don't recommend that especially on user workstations. Maybe if you've got some sensitive equipment out there, maybe you want to run it on your web server just to get an idea. But otherwise, if you poll once a second, it'll show you all the new stuff. Socket dataset. This is Linux only. Does not work on Mac. Monitors network traffic. Does what it says. So one of the downsides, if you use auditd, you can monitor socket connections, socket creations. But with auditd in Linux, it only shows you one side of the connection. So it'll say incoming connection from this IP address, or outgoing connection, with this source IP. And you don't get that full connection information in a single event. You have to really work to get that all together in auditd. So with the socket data set, it gets you all that information. And in 7.4, we completely retooled it So now it uses K-probes, so there's no more polling, so you get all the events, and it shows all the flow information. So you get packet byte, packet count, when that, as soon as that connection is over, you get all that, all that data you'd come to expect from Bro, but you've got it on the host with all of the process information to enrich it. So you know exactly who started it, how many packets they sent, where they sent it, etc. User data set, Linux only, does what it says. Also shows when when passwords are changed, which is kind of nice to see, okay, when was the last, once you've been collecting this data for a while, you can say, hey, when was the last time this user changed their password? All right, so now I'm going to talk a bit about configuring the Auditbeat, because you can't just if you just take Auditbeat, use the default configuration, and deploy it to your entire domain, you're going to have a bad day. You need to tune this, everything. So it gives you a YAML file. Inside of this file, you can configure exactly which modules are run, exactly how often they poll. You can whitelist, you can drop events. There's lots and lots of configuration. Like I've started into this for all the workstations, and I thought I was doing pretty good. And then our cloud guys showed me their config, and I think it was like 500 lines long with all the whitelisting they do and exclusions and syscalls that they collect. So, some people know it a little better than others. The config file controls everything about Auditbeat, basically. So this is one of my favorite processors. So, don't collect something if you're not going to use it. And we're doing this on all of our endpoints. So we've got privacy concerns. We've got employees all around the world, different concerns, so we don't collect browser data. So I say, okay, drop all 443 traffic from Chrome. So you can do ORs and ANDs, and you can have as many of those as you want. So, the OR statement, you usually just start out with one OR statement, say if it matches any of these, drop it. So if it's an existing process, process error, process stopped, anything that's a field in Elastic, you can just, do that, like process, destination.port 443, destination.ip, goes in pretty easily. So you can just make a whole list of, events that you want to filter. And so we try to do this about once a month, where we go in and look at the config, and you say, okay, what are unnecessary noise in my cluster right now? I've got this one system creating this error log that is, sending me 100,000 events a day. Okay, well, let's push that so it doesn't show up to my cluster. So then I stop getting billed for that, and everybody's happy, because now I don't have noise in my system. I'm not paying for it at the cluster level. It just gets dropped. And the ORs and the ANDs, you can nest those if you want. You can have some pretty complex drop statements. These are some metadata processors. So the top one, so by default, the process socket set won't include all of the parent process information. It'll just have the parent process PID. So you can do this. So now as every process comes in, you get all of the process information as well as all of that process's parent information as well. So you'll get the parent process, current working directory, the parent process, command line, etc. So then in a single event, you have a lot more context in order to make your decisions. The cloud metadata one, so interesting note. So when you turn on the cloud metadata, it says, okay, I'm in the cloud, but I have no idea which cloud I'm in. So it will try to talk to that AWS service and get information about which cloud it's in. So the 169 or whatever that IP address on AWS. So if you see your Auditbeat making connections out to this, don't worry, that's actually okay. But because it doesn't know which cloud it's in, first it does a discovery. So, you may have Auditbeat deployed in AWS, and you'll see it making DNS queries to Azure, to IBM, to all these different cloud services, to Tencent, because that's a big cloud provider in the world. And so that may freak out some people in the US to say, hey, my systems are making DNS queries to Tencent, or vice versa. So just one of those things to consider. And then the host metadata, that can add a lot to your storage if you do that, but it's really nice to have. So then every single event has all of the host information as well. So you get the host ID on every single event. But that can make for some really nice dashboards. So then you just pop in the host ID into your search bar, and bam, you've got every event for that host. The queue. This is something that I learned about, and it is very important if you have a laptop. So this is basically says, okay, store all the events in a nice little file when you're offline, when you can't talk to the internet. As soon as you plug back in, it boom, sends all the events. And you can control that buffer as to how many events it sends at once. I put it 10 megs because, that's in the grand scheme of things, not too much. If you have some users on some really bad network connections, they may complain about that. Things to consider. So if you're deploying Auditbeat out to a bunch of laptops, anybody with root access can modify and view the config. So do not put any sensitive information in there. Don't put a password to your Elasticsearch cluster in there. I recommend, and what we do is we ship it to Logstash. So then, yes, you have to deploy, the certificate so that it can talk to Logstash, and an attacker could get that and flood your Logstash with bad events, but they can't log into your cluster. So it's, definitely a trade-off there. So, all right, going to get into threat hunting, alerting, and incident response. So I like to break down what I can do with this information into 3 different categories. Because host-based events, there's a lot you can do with them. There's a lot of information there, and sometimes it gets overwhelming as to where to start. So you can break it down, and so if you have a large enough InfoSec team, you can break this down into multiple teams as well, so that each person focuses on their own thing. So real-time alerting, I put that in quotes. Because it's polling, because boxes are offline, and you're using watchers, it's not real time, but it's close enough. Threat hunting, that definitely is the big category that I like to do, and then the incident response and forensics timelines. Get into that a bit. So alerting, so watchers in Elastic, you can use watchers to basically run a query every X number of seconds, minutes, hours, and then any results to that search query, you can then do whatever you want with them at that point. So you can detect living off the land, AV mist. So let's say you do a search query to say, hey, every time this command is run, that your antivirus doesn't care about at all, but I care about because, I want to see it. Because this in my network, I know this is bad. So I can make my custom antivirus signatures like this and get alerts with it. So with watchers, so there's a ton of watcher Sigma rules out there. I'm sure people in this room have heard of Sigma. SOC Prime has a nice tool, Uncoder.io, to take those, convert them into watcher rules pretty quick and easy. And then from there, you can have your alerting is basically a webhook. So we send ours to Slack and the Hive and InfoSec and Elastic. You can do whatever you want with them. We actually were discussing an Alexa skill that will, play a sound every time an alert fires, which my family would very quickly not like. One person mentioned he'd like to think of alerts like the severity level of alerts as whine, growl, and bark. And that was an Alexa skill we were discussing, which, would get turned off very quickly. Something to consider when if you're doing this type of thing, ingest time versus actual event time. So when you write a watcher, you have to specify which, okay, look at everything that with a timestamp of the last 30 minutes, and then, show me if there's any new hits. So which timestamp do you look at? Because a lot of events, do you have the timestamp when the event actually happened or when the event hit your cluster? And so we use when the event hit the cluster, because let's say I take my laptop and I fly to California, which 10-hour flight or something, and I didn't pay for Wi-Fi, so I'm offline. While I'm on the flight, I go fall asleep, somebody uses the evil charging cable attack or something on it, add some malware to my system. I land in California, finally get to my hotel a few hours later, and then now I connect to the internet. If my watcher is only looking at events that actually happened in the last 30 minutes, it'll miss that entire flight. So you have to look at when it actually hits your cluster with the ingest time. That little code there, that's the one line it takes to your Logstash config or your ingest config on Elastic to add that. So now you've got the actual time when the event happened versus the time when it hits your cluster. So incident response and forensics. So if you have all of the data all ready to go, then why do you need to go pull a hard drive? So you can make all these dashboards ahead of time. I'm not going to go in too deep on this. I actually gave a talk on this with the Windows systems at B-Sides Munich. So that's the link at the bottom for that video that Cooper was nice enough to video. You can basically make the dashboards and timelines so that when somebody has a question, when you have an alert that fires and you're wondering, this doesn't look right to you, instead of going and, getting physical access to a system to go investigate it, you just go look at the dashboard and you can usually answer your questions. Threat hunting. So threat hunting, based on the assumption you've been compromised, you assume compromise, and you say, the attackers are in a network and I haven't caught them. Now what? Cyclic process, it never ends. You're just constantly adapting, and sometimes you do the same hunt, multiple times a year because, maybe the attackers came in during that time. My recommendations, keep each hunt narrowly focused as possible. Sometimes people say, I'm going to hunt for bad guys, and that's okay. Hunt for bad guys doing one specific thing. And then, once you've determined whether they have or have not, and that data's in your logs or not, then you move on to the next one, and you adapt and you say, hey, I wasn't able to complete this hunt because I don't have this data. So what do I need to do in order to get this data into my cluster and into my hands so that I can do this investigation? The more data you have, the better. Once again, it's a balance because data costs money. Logging costs money, so you got to balance that out with all your needs there. Oh yeah, and that last line, the more information you have in a single cluster or viewable by a single cluster, the better it is. If you have to go to one place for your endpoint protection and one place for your network logs and another place for your proxy logs and another place for your AWS logins, that you cannot get good visibility that way, and everything takes longer. All right, so threat hunting on Macs. So this was kind of an experience for me because I've been a Windows person for the last 5 or 6 years. My number one programming language before this was PowerShell. So now I'm, Mac forensics, Mac investigation focused. So Mac, they lock down the systems, which is good for security, not so good for visibility. You don't get socket, you don't get login, you don't get user information. We're working on that. Just bought Endgame, so now they've got an agent for it, so maybe that'll help us out a bit. There's also relatively few write-ups about Macs, about compromises, about malware. There's Objective-C, that's the one website I know of that has a pretty good collection of Mac-based malware and attacks. So then you can kind of go and say, okay, let me look at this attack and how would I detect that? Let me look at this next one. How would I detect that if somebody came at us with this attack? All right. So the big thing that I've been looking for with the Mac data, so you don't have the socket information, so it's kind of harder finding the beaconing type stuff, but you can find you can do a pretty good job of looking for persistence because Mac it's only got a few places for persistence, and they're fairly well documented, so you can watch for changes to those. So then, the big thing is the launch agents, the launch daemons. Some of them run as root, some of them run as users. Every time you install a new app, if it starts when you boot up, it installed a launch agent or a launch daemon. You install most of the time. I've got alerts for all of these when something new gets installed, and most of the time it's Keybase getting installed or Slack getting installed or something like that. But that's fine. I'm okay with that because I can sift through those and then or I can just drop those specific processes in my config, and then I see everything else. So yeah, I monitor them with the file integrity module as well as watch for any processes where those folders are in the arguments. This is just a quick config. I don't know if you can read that. So you can see the launch control load. That's the command that you run to actually load a process so that it gets loaded every time on start. Or you can just use VI to edit the plist file, and the next time it boots up, it'll get started on its own. So that's why you want to monitor for both. This was just a quick snapshot of this is the last 7 days. So we've got 1,500 systems, and this is over the last 7 days. So you can see it's not too noisy as far as alerts go. Once you tune out the actual noise, and I think I'll probably add the Keybase Keybase updater to my whitelist, so I don't see that again. Kernel extensions, so kexts. So this got changed in Catalina. So if you've updated to Catalina, then this doesn't quite apply. But Mac didn't, communicate that well with a lot of the developers. So I think they still support it, but they're saying on the next version they're going to cut it off completely. But a kernel extension, so like the kernel extension I see most often is Google Drive. So people install Google Drive so that when you open up Finder, you can actually see your Google Drive folders within Finder. That's an extension of the actual kernel of the operating system. So these, as you can imagine, these are, could probably be done as a rootkit type thing. It changes how a lot of the functionality of the actual computer works. So you watch that system library extensions folder. You can do kext. Yeah, so kext load is the process that'll actually load it. You can do kext load list. If you want to see all the process or all the kernel extensions currently loaded on your box, there's a command you can run on the terminal if you're root. It'll show you all the kernel extensions. So that's a big one that you want to watch for. And also be prepared to whitelist noise. Certain environments like Google Drive, okay, everybody's got that in my environment. Let me get rid of that. So cron, Mac under the hood is a Linux system. It has cron installed. The only application I've seen using cron on our network is kube control. So our Kubernetes developers, they're constantly setting it off. Everybody else, I don't see any cron execution on the other 1,600 Mac systems. So it's there, it works, it will start things at boot up, but it's not used that often anymore. Definitely one of those things to keep an eye on. Defaults. It sets the defaults. It was a bit of a confusion when we started a conversation on this. I want to look at the defaults. Okay, well, what do you mean? The actual command is called defaults, and it changes the defaults. So if you do defaults read, it's a huge it'll spit out a big JSON with all the defaults on your Mac. And you can write, it's just a plist file. You can take a plist, write it to that, and now your defaults on your Mac have changed. And this can be used to say, okay, every time you start up, run this command. One of those things to keep an eye out on. Private Etsy, it's kind of like the Etsy folder on Linux, but Mac, they had to be different. They put it under private Etsy. So definitely, there's a lot of stuff in there that can be used to boot up or to cause execution on startup. So you like bash rc, system-wide bash rc file. So every time somebody starts up a terminal, this gets run. Man.conf, you got users that are developers. You modify this every time somebody runs a man command to look up some documentation, they execute malware. A lot of interesting ways you can do this. So watch for changes in there. It shouldn't be changing a lot, so just keep an eye on that. Malware execution. So we watch for sudo. Anytime sudo gets run on the box, because all of our engineers are out there and a lot of them have Macs, we see this a lot and we've done a lot of whitelisting on this. But if you've got, let's say all of your marketing team has Macs, you shouldn't see sudo being run on the marketing system boxes that often. So this is one of those things that you've got to monitor. This comes into the threat hunting. Like you don't want to have an alert waking you up or barking at your Alexa on this one. But it's one of those things that you review once a week. Python, if you look at Objective-C, you look at a lot of Mac malware, it uses Python for execution. If you look at PowerShell Empire, they've got a Python version that works on Macs for command and control. If you want to do some red teaming pen testing on Macs. So keep an eye out on Python. Once again, in a network full of developers, that gets tricky. So just kind of machine learning can help with that, where if you're looking for strange execution of Python, like you see the same thing getting executed over and over again, and now here all of a sudden you see this system that's never run Python or this Python command that's never been run in your domain, that can really help with a lot of that stuff. And then the big ones, parent-to-child process relationships. If you see Microsoft Word spawning a terminal and then suddenly, and then a chain of events leading to it modifying Etsy hosts, and that's that lineage that's one of the key indicators for a compromise. Malicious apps. This is one of the challenging one. If you look at most of the Mac exploits and vulnerabilities, compromises, it's somebody installed an app that they shouldn't have installed. And Mac does a fairly good job of locking it down, and they've even made it harder now with Catalina to install third-party apps, which I heard like even OpenOffice now is not installing or not working right on the newest version of Mac because of this. So is what it is. But from a security point of view, that's better because it makes it harder for our users to install a malicious app. But the big thing to look for is look for rare apps installed on your fleet. And then when you see an app, do some research. We have people all around the world. We have employees in China, Australia, everywhere. And so I definitely see some local apps that, like, hey, this one's common in Korea, but I've never seen it anywhere else. So, worldwide type of organization, you start to learn all these local apps that everybody likes. All right, threat hunting on Linux. This is my life on the Linux systems. So get familiar with all the Linux admin queues. The first place I go when I see a Linux alert is to our Linux admins GitHub, because we put in like issues every time they're doing maintenance or changing things or changing configurations. And I just do a search for that system that fired the event, because 99% of the time it's in there. If not, I look at the username or who's logged into that system and I Slack message them. Because if you set off all the alarms, hey, I've been infected, there's an APT, every time you see something crazy on Linux, you're going to, very quickly be the boy who cried wolf, and nobody's going to talk to you. So threat hunting on Linux, exploit detection. So there's a lot of this is straight out of Sigma rules. So dev TCP, look for, web shells, things like that. So for most of the Linux systems I monitor are part of our build infrastructure in the cloud, not so much on the workstations. So you don't see netcat running that often on those systems. You don't see wget unless some command or script is running it, and then you whitelist that. Look for strange things. This really is the key to the Linux box, the Linux threat hunting. The machine learning, that's one of the things that I wanted to talk about with, it's really good in say you've got an environment with lots and lots of containers, and you stand up a new container, it does stuff, and then it tears down, and it's this ephemeral type action. You see the same commands being run over and over and over again. So the machine learning is pretty good at saying, hey, this just gets to be part of the normal baseline, and human activity stands out like a sore thumb. So your machine learning says, hey, somebody was logged into this box at this time. And then that's where I go over to the Linux admin queue to say, okay, what were they doing? Okay, yep, somebody was actually logged into the system. Focused alerting, definitely. So that link there, that's a Sigma rule that Linux suspicious commands, it's like 20 different commands that are all suspicious, and that's great. And I use that, but I really recommend breaking it up into individual rules. Because if that comes off as one alert, it's like, hey, a suspicious command was run on a Linux box, that's okay, thanks. You can break your alerts up so your watchers show you exactly what the rule was. And it's my personal preference, it's better to have 20 rules as opposed to one. All right. Just an example of stuff I see in our network, okay, yeah, that looks bad. That specific command, that installs MISP. So, yeah, okay, cool. This is the life of threat hunting on Linux. You see some crazy things, and then you just got to verify. Because a lot of times the admins and the attackers are doing the exact same type of commands. And yes, context is key. So look at the process, look at the surrounding events. If you can see an admin logged in and they updated Docker, they updated a bunch of things like that, and then they ran the suspicious command, usually the attackers don't log in and update your Docker images and update other things before running their suspicious command. All right. So conclusion, endpoint visibility, that's from an InfoSec threat hunting point of view. I started out doing the network visibility stuff, and I was very quickly frustrated with how much I didn't know. And now with the endpoint visibility, it's very quick and easy to answer your questions, to get that context, so that every time you see something weird, you're not, setting everybody up, waking everybody up for false alarms. But the NetFlow, all that stuff, if you can have all that stuff in the same location, then now you've got all the context. You can say, okay, this network connection seen here, was this process and that was bad. Now, quickly expand out to say, show me all of the other systems and processes in my entire domain that made that connection. And yeah, the obligatory, we are hiring just like everybody else. Like I said, Elastic, we don't care where you live, so you can, sit in your house and work for us. So down to the question section.
Do we have any questions? The audience? Nope. Yes. Oh.
Hello, thank you for your talk. For the host ID, which is persistent, even if you change your host name, does it work over reinstalls? Or what is it actually based on to generate that host ID?
It's generated when the Auditbeat is installed. There's some algorithm for generating the ID. I can't remember exactly what it was, but so yes, if you uninstall Auditbeat and then reinstall Auditbeat, I believe it gets. I'm not 100% on that, but I'm pretty sure it gets a new host ID. So in cluster type, in a container type environment, if you just have your container script install Auditbeat as the container is built, each container gets its new, even though it's a copy of the same exact image with all the same hardware settings and everything, every time it gets a new host ID.
Hi. You mentioned cloud discovery in Auditbeat. Is that on by default, or do you need to enable it?
I can't remember if that was in the default config or not. It's the cloud metadata functionality. I believe that's on by default. So yeah, I can't remember that. I've been looking at my config so long. It's been a while since I've actually looked at the default config. But it's a quick one-line thing to turn on or off. And the data in there is pretty nice because it shows you which cluster it in, what the cloud account. So we have a lot of accounts. So we have customers that use our cloud infrastructure. So when I see an alert, I've got that and say, oh, this is the exact the Google GCP account for that alert. And so then I pass that over to our cloud security team, and they know exactly, okay, that was this customer, that was this image within their cloud. This is the cluster that they were in, or the image. So all that information really helps in a cloud environment.
Okay, thank you very much. Yeah. So yeah, I think we can give him a round of applause and.